Okay, so we will start by looking at the expansion of two binomials. Expansion of two binomials. Good. So we say expanding an expression means multiplying it out. The term binomial refers to two different terms which are supposed to be multiplied. Mostly it is either given in a bracket or it can just be given in a figure in a bracket raising to a power 2. It may depend either 2 or 3, but in the bracket you have two different items separated by an operation sign. It can either be addition or subtraction. If they are together, if it's a product, that one is considered as a single term. Let us look at common examples of such. So we see the example. We have 6 minus x by 6 plus x. The term by indicates multiplication at this regard. In solving this question, all we need to do is, let's see, this is our solution. We get back our function again, which is 6 minus x. By indicates multiplication, so multiplying by 6 plus y. In general terms, when you got an item to be multiplied like this, it means everything in the first bracket is multiplying out everything also here. I use the equivalency sign. This one is equivalent to sign for you to know that this whole thing is equivalent to 6. I bring a bracket, then I bring, this is the first 6 I've taken, is multiplying 6 plus y, and I maintain the operation sign as I did in the numeration system. The negative sign comes out, negative x, also multiplying 6 plus y. Okay, I will now look at the expansion of this. So we have this as 6 plus y, 6 plus y in the open bracket. Now the external aspect, this aspect is what has been shared out, so it's going to multiply out completely. So what I have is 6 times 6 will give me 36. Then 6 times y will give me plus 6y. 6 times y is going to give me plus 6y. Then the operation sign, the minus sign is supposed to be there. So over here, x times negative x times 6x is going to give me negative 6x. And negative x times y will give me negative xy. Do we have some items which are common? Okay, so in this point we can then decide to group it in this manner, because there's y in this aspect and there's y in this aspect. We can just factor the 6 out. We still have x minus y, but it is not needed. So what I'm going to do is that I'm going to get 36 here. Now I let those with y be at one side, minus 6x plus 6y minus xy. So this one becomes my solution. Why do I leave it this way? Because there's no way I can add xy and 6y. They are not the same. As a matter of fact, we know that we can only add variables if the if they are the same and they have the same power, but this one is 6y and this one is xy, they are two different things. And neither can I add 36 to minus 6s, because minus 6s is also a different thing, and you cannot add minus 6x and 6s. The best you can just do is factorization. So when we get to factorization, this aspect will be explained. The binomial expansion can also come in either what is called perfect square. Good. The binomial expansion can either be a perfect square or difference of two squares. What do you mean by when it is perfect square? Good. So we say when the factors of the binomial terms are the same, we call it a perfect square. Example include x plus y to the power 2. Now during the expansion, we can see that this x plus y will remain as x plus y and x plus y again. So the terms, the factors of each of the terms happens to be the same. So we call this one a perfect square. So during expansion, we are going to get x squared here is going to give me x plus y. So like we did earlier, we have x multiplying x plus y, that is the first term, multiplying out the second term, plus y also multiplying out x plus y. Good. Let me go a little bit up. Good. So what it means is x will multiply s. We know the law concerned in multiplication. When we are multiplying, we add the exponent. So x1 is going to give me x to the power 2 plus x times y will give me xy plus y times s in arrangement. X comes before y in alphabetical order, so we'll bring x first before y. Then y and y, they are the same, so we will add the exponents. That is going to give me y to the power 2. In that regard, what we have is that we have x squared, then I have xy, they are the same. So in that case, because the variables are the same, you only add the coefficient. So there's one here which is not written, and there's another one here which is not written, but because the variables are the same, you can now write them. So I'm going to get plus 2xy plus, this one is solitary, it is alone, so you write here y squared. So this one becomes the solution to this function. Let us look at more examples which are BEC as questions. Okay, so we've got 2a plus b all squared. So solution. To solve this, what we need to do is, as usual, we have our 2a plus b all squared. This one must be equivalent to, now we got 2a plus b, 2a plus b. Because the factors are the same, it is risen to the power 2. Always bear in mind the figures in the bracket must not be to any higher power apart from 1. Then when you see such and it is risen to the power 2, it is a perfect square. If it is risen to the power whatever is in the bracket, the binomials in the bracket have the same factors, so we have to expand this. So in expansion of this, we are going to get my 2 out 2a, that's the first term, which is going to multiply out 2a plus b in this regard. The same thing also coming from here, b out, we got 2a plus b. So I can now expand the bracket. Now look, we got 2 times 2, which will give me 4, a and a, which is basically going to give me what? A squared. Then 2a and b, the variables are not the same, so we put them together. So we're going to have 2ab. So the first term has been multiplied out. We go to the second term, plus b times 2a will give me 2ab. This one has been arranged in alphabetical order, plus b squared. So what do we see? We got 2ab. They happen to be the same. They have the same factors at that instance. So since they happen to be the same here and there, all we need to do is to make sure we put them together. So in that shape, we're going to have 4a squared plus 4ab. That means 2 of this and 2 of that, plus b squared. Good. So this one becomes solution to the question. Okay, difference of two squares. Said they are binomial terms with different factors. These are binomial terms with different factors. Example include, now we have x plus 1. Let us take the examples we have, and let's try the examples. So solution to the examples. Good. When we have x squared, that is x squared minus 1. Now we can clearly see that 1, the factors of 1, numbers that multiplies for us to get 1, negative 1, this is negative 1. So x squared minus 1, you can see 1 times negative 1 will give me negative 1. So it means that the factors are not the same. So with this, I'm going to get x minus 1, x plus 1, indicating that the factors of 1 are not the same. So when you expand this, you are supposed to get this. The other one include, that is the ii over here, also, which is x squared minus y squared. Now let us see what we are going to get. X squared, y squared. What are the factors that will multiply for me to get negative y squared? It is it can be positive y times negative y will give me negative y squared. So it tells me that the factors of this y are not the same. So because they are not the same, then we call it difference of two squares. So this one becomes x minus y, x plus y. It means that it has already been solved. So you don't go further and say you are expanding again. That is the general expand, because if you try to expand, you still come back to this. And the last, not the least, which is we got 9x squared minus y squared. So this one is, now look at 9. 9 is a number to a power. So 9 can give me, this one can be given as 3 squared x squared minus y squared. Do you see that? So 3 squared is the same as 9. Then x squared is still x squared, and y squared. Y squared has two different factors, as I explained here. So this one is going to give me 3, 1 of the x minus y, and another 3 x plus y. So in this regard, anytime you'll be seeing a perfect number with a variable and the other one is open, is difference of two squares. If you check your BEC past questions, you have got a lot of this as an example. So this are some of the few things you need to know on this session. The example we are going to take is going to be theoretical question. Okay, so these are some trial questions on the topic. These ones are not perfect squares or difference of two squares, but they are general binomial expansion. So what you can do now is that you can pause the video and try and see if you can do it. Okay, let's all work together. Solution. The term is multiplying 3 plus x by its multiplication. So I have got 3 plus x by 5 minus 2x. Okay. Now I like using the equivalency sign so that you know that I'm working an expression. So this one is going to give me, this is going to multiply out the whole of this term, likewise x. So I'm going to get 3 5 minus 2x plus x 5 minus 2x. Okay, so I do my multiplication now. 3 times 5 will give me 15 minus 3 times 3 times 2. The negative is what I've already brought because it is the operation sign in this regard. So 3 times 2x will give me 6x. Good. Plus x times 5 will give me 5x. Then x times negative 2x will give me negative 2x squared. You know what to do. So because this one, the middle part, this is x and this is x, then we can do something to 5s6 minus 6s and 5s. So we arrange it having 15 then minus x, meaning if you owe 6 and you have 5, you pay the 5 out and you are going to get it. And I explained the other time that when you got this negative 6s, it's not a number, but it tells you negative x is occurring 6 times. 1 2 3 4 5 6, and you have x x x x x. So when this cancels this like that, one by one, you are left with x. That's what got negative s minus 2x squared. So this one becomes the solution to the question. Okay, so the second part also is multiplication. Say find the product. Product means multiplication. So we have the product of these numbers. So let us see how we go about it. So I have my solution. As usual, I'm going to have my 2x minus 3, then x minus 1. I bring my equivalency sign. What do I have now? This 2 is going to multiply out this, so I'm going to have 2x out multiplying x minus 1, then minus 3 out also multiplying x minus 1. Good. So what happened is that I open the bracket now. So 2x times x is going to give me 2x squared. Then 2x minus 1 is going to give me minus 2x. Then minus 3s times s is going to give me minus 3s, and negative 3 times negative 1, we say when we multiply negative by negative we get positive, so you're going to get plus 3. And we realize that the middle parts, you would always have to check it. This is to the power 1, this is to the power 1, but this one is to the power 2, so we're going to get 2x squared minus 5x. Why are we adding? Now you are owing somebody 2 and you are owing another person 3. This is different from when negative meets negative. So this one, you are owing somebody 2 and you are owing another person 3. So it means that you are owing 2 different people and your debt increases. So we're going to have negative 5x plus 3. So this one becomes solution. Good. These are all past questions. The first one we solved is a BEC question as well as the second one, which is also a BEC question. This one we just solved is 2008 BEC theory question number 5C. So all the examples have been given are also wire-based BEC questions, so they can use for such preparation. Factorization. We are going to look at the various forms in which we can factorize a given expression. So we say this is done by first grouping in pairs the terms that have common factors. Grouping in pairs the terms that have common factors. Can just let me put my terms here. Grouping in pairs that have common factors is okay. Always make sure after grouping the terms in the bracket after factorization have the same factors. Always make sure after grouping the terms in the bracket after factorization have the same factors. Let us look at some examples. So we see the question says factorize completely the following: I 2xy minus 8x plus 5y minus 20. II 22ab minus 11ac plus 6rb minus 3rc. Okay, and the last one is b squared plus fb minus mb minus fm. Now all these are past BEC questions, so at that level everything has been arranged in a simple form, or in the simplest manner in which you can just do your groupings. Let's start. Solution. We have 1, that is I, 2xy minus 8x 5y minus 20. Okay, now we are going to look at it and look at how best we can arrange it. What must be on the back of our mind is that after our pairing, what will be in the bracket must be the same. If I look at, I've got 8x and 2x, so we got x here. Don't worry about the y. So in this case, I'm just going to put 2. Let me use blue ink. I'll first put, because it has been made for me, 2 xy minus 8x must be in one bracket. In between the two, there must always be additional sign. In between one bracket to the other bracket, there must always be additional sign. So I've got 5y minus 20. Okay. So I look at here, what are the common terms? Now 2 is a factor of 8. 10 factorization means to bring the common term out. So 2 is a factor of 8. So 2 comes out. 2 comes out first. Then what again is still common? There is x here, there is x here. So x will definitely come out. Good. So you are now going to factorize. In factorization, it's like you are dividing algebra. So when we said 2x into this is the same as what is at the top here will be considered as 2xy now divided by 2x. So what happened is that the 2x is common, so it will cancel, leaving y. So we said 2x goes to 2sy, you'll be left with y. And again, when we got minus 8x divided by 2x, x cancels x, and 2 will go to 8, 4, which is minus 4. So here I'm going to get minus 4. I close this bracket. My operation sign still positive here. The commonest term that can go into 5y and 20 is 5. 5 is there. 5 can go into 20 and 5 can go to 5. So we got 5y divided by 5. So 5 cancels 5. We are left with y. So we have y here. And as we did earlier, 5 will go to 20 minus 4. Good. That means 5 will divide 20. You are left with minus 4. Okay. Okay. So as I said earlier, for you to be sure that whatever you have done is correct, make sure that what is after the factorization, you have the same thing in the bracket. So the left hand side bracket, I've got y minus 4, and this place also gives me y minus 4. So when I've got this, the only thing I do is that I now pick my answer. So I've got what is out, 1 is taken, so 2s plus 5. This is out. You pick what is out here and that. So I have in the first bracket, the outside figure, I've got 2x plus 5. Then I pick one of these brackets, y minus 4. So that one becomes solution to the question. Okay, let us look at the remaining. Good. So as we did in the previous example, likewise we are going to do. We just have to look at terms that are common. Now I can see 11 is a factor of 22. A is also common here. Okay, so if A is common, then that means the commonest term factor here that can go into this is I've got 11 first. I've got 11 first, then A is here, so A2 is also common. And I'll bring my bracket. So this term must first divide the first term. So the first term is what? 22AB divided by 11A. A will cancel A first, and 11 will go to 22, 2. What am I left with? 2B. So 11A will go into 22AB, 2B. That is the first instance. Good. Then 11A will go to 11AC. This is it. 11AC divided by 11A. Okay, 11 cancelled 11. A cancel A. I'm left with C. And the operation sign here is what? Minus C. I close this. I said always in between one bracket to the next, let there be a positive sign. and the least term here, the commonest term, is 3 here, because 3 can go into 6. So, and again there's r here, so I first bring my 3 out, then r and r is common, so I bring r, I open my bracket. Okay, so as we did in the previous example, let me go a little bit up. What we have is, we have 6rb divided by 3r. R will cancel r, 3 will go to 6, 2. We got 2b. Automatically we know 3r will cancel 3r. We are left with minus what? C. Good. So what do we see? You realize that after factorizing, what is in the bracket happen to be the same. So we pick out what is out, which is 11a plus 3r is out. Then what's in the bracket? When you are finalizing, you put them together like this. That is when this one has been, because the operation sign for this one is the positive, which goes with this. So what is in the bracket? You pick 1, 2, b minus c. So this one becomes solution to this one also. Good. So what we see now is, we try to look at this, grouping it. What we have is, we first put this one in a bracket, b squared plus fb plus the negative here must go into the bracket, so minus mb minus fm. Okay, so we now do our factorizing. Good. So what we have here, the commonest term, there's b squared b, so b is common term here. So if we are picking b as our term, then b goes to b. We say when we are dividing, we subtract, so it means that I'll subtract 1 from this, I'll still be left with what? B. So we have b here, plus b cancels b, I'm left with f. Good. And if I look at here, is minus mb and minus fm. Here is positive, the function here is positive, so although this place must be positive, but we have the common term that is coming out must be negative m, and when positive meets negative, we say it's negative, so here we have negative m here. So we got negative mb divided by negative m. We're going to get what? B. So we get b. Then negative fm divided by negative m. Negative cancel negative, m cancels m. We are left with what? Plus f. So when negative cancels negative, this f becomes positive, so we have this. So finally we have got b minus m, then b plus f. Okay, so this one becomes the solution.